Hi all, welcome to module P11. This will be a power-packed module that introduces us to the basic concepts of authentication, password hashing, a command line tool called curl, which is one of the most useful and versatile tools for testing HTTP and API endpoints, and the concept of sessions and how to implement them. We'll be looking at implementing a basic password hashing and storage mechanism. We'll also look at the concept of salting a password and why it is required. Apart from implementing a login endpoint, we'll also have a user creation endpoint. We'll then implement a cookie-based session system, and then we will test our APIs and endpoints using curl. Let's head to our coding console. All right. So in the last session, we left off at creating a testDB endpoint and an articles endpoint, which was talking to the database. We'll first, to start off with, look at creating a password hashing endpoint. So what we would like to do is create an endpoint that takes an input from the user as a part of the URL and returns a hash string which represents what the password will be stored as. So just to sort of write a pseudocode, what we want to do is we extract the input value, and then we have a function called hash which we haven't written yet, and if we have this function called hash, and then we will return this string back to the user. So this is kind of what we want to do. Of course, we need to have this function called hash. So let's write the function hash here, which takes as an input the input. And what it should do here is return the hashed value, right? So what we need to now figure out is how do we create a hash. So we'll be using the default library called crypto that is a part of Node. So if you head to the documentation for Node.js, you will see a library called crypto, and there if you go to, and this function provides us a way to create a hash of a particular input. So for example, here a value called secret is taken and a hash is returned. So let's see what that looks like. So this is kind of what we need to do. Copy the function name here. Now of course we need to have crypto here, so let's include crypto. So we included crypto, so now we have the crypto library. Now what we need to do when we hash this is that we need to give it the input. We need to give it something called a salt. We'll understand what a salt is in a little bit. The next argument is the number of iterations. So this is the number of times the hash function will be applied, and again we'll understand why we are doing a certain number of iterations. So let's say we do 10,000 iterations, after which we'll use the standard default values that you want a key length of 512, and we want to use the SHA-512 digest. Let's not worry about what these are just yet. So this is what we'll do, and we'll return hashed. Of course, what we need here is the salt value. So let's take the input called salt from here, and that means that we need to pass an input salt here. For now, let's say we create temporary salt value. Let's just create a value called this is some random string, right? So I just created a random string here. Now when we hash this particular value, the output that we get will be a sequence of bytes. So to convert that into something that we can read, we are going to convert that to string and use the hexadecimal encoding to convert that into something that is readable and printable on our screen. Now let's first quickly see if all of this works, and then we'll come back and try to understand what this function is actually doing, right? So save this code. Go to our app. And so I typed hash password, and this is the output that I got, right? So that means that our hash is working. Let's try to hash this again. So you can see that I've called the endpoint here. I refreshed it, called the endpoint again, you can see that the value of the hash does not change, right? But if I change this and I make a small change in the input and I make it say password 2 and I refresh it, you can see that the entire value looks fairly different, right? So that means that what is happening is that it is converting this string into a 512 byte string, right, which is a random value. Right? This is how we store the user's password, right? We won't actually store a user's password as password to raw. We'll store it as the hash. So let's just try it out for a few more things, like for example test, right? I refresh this, it stays the same. Great. So now let's take a step back and come back to understand what we're doing when we call this function. So what this function does is that it takes our input, it appends the value of the salt, right? And then it applies the hash function 10,000 times, right? Why do we do this? Why are we simply not just doing a hash of the input? For example, if you go to the crypto library, you'll see that there is a function called create hash. And what create hash is doing is that it's taking a particular input and it's converting that into a hash value, right? So why are we just not using a hash, right? Why are we using a special algorithm which is called the password based key derivation function? Right? Why are we using this? The reason is that if we just save the hash without adding this random string, the hash would always evaluate to the same value for the same algorithm. So for example, let's say that the algorithm is MD5. So MD5 is a known hashing algorithm. Now let's say we're using the known hashing algorithm for hashing a value of password. This algorithm will always hash the value of this string password into some value, let's say right. So let's say it converted this into this value. Now every single time the same algorithm is applied to this same string, this is the value of the hash that will be generated. This is good because given this value, there is no way I can figure out which string it came from. But what is a common practice amongst hackers is they maintain a set of tables which store the commonly hashed values, right? Which store the commonly hashed values of common strings. So that way, they don't have to try to determine and reverse engineer where this hash came from, but instead what they do is they just look a particular table up and they find out that for what string is A8Q2RASDF a hash. So they're able to do that, and then they'll see that this belongs to the string password. To protect ourselves from that, what we do is that we append a salt value to it. So now the value that will be hashed is this. This value will of course have some completely different hash value, right? And there is no table in the world that will have stored this particular hash value, because if we choose our salt string randomly enough, then there is no way that somebody would have pre-created tables that contain the hash values for all the commonly known strings. And that way, even if users use strings that are very common words for passwords, for example, password or common names, even then, by adding this random salt value, we can ensure that the values of the hash generated are unique and cannot be reverse engineered. Further, to protect ourselves even more, we hash the value 10,000 times, which means that a particular value password is first taken. This is then converted to a value that contains the salt. This is then converted into a hash, and this is converted into another hash, and so on 10,000 times, right? And so the final value that is obtained of the hash is certainly not going to be present in any kind of a lookup table or a hash table somewhere that will allow hackers to find out what the original string was, right? So now that we've done this, let's make our hash function return a slightly different string, and we'll understand why we're returning that string a little later. So let's create an array of strings where I first store the name of the algorithm that I'm using for doing the hashing. I'll then store the number of iterations. So that's 10,000 iterations. I will then store the salt value. And after storing the salt value, I'll store the hashed value, right? And then once I have these values, I will join them with the letter $, right? So let's save this. So the string that we're returning contains the name of the algorithm, the number of iterations, the random salt value, and then the final hashed value. What is important to know is that even if a hacker has access to this entire string, which is the hash value, the salt, and the number of iterations, and the hacker also knows that we are using the algorithm PBKDF2, there is no way that the hacker will be able to figure out that this hash actually comes from the string called test. And that's why this is the string that we'll actually store inside the database. Let's go ahead now and create our database that will store the username and password for the user. So let's head to our database console. Let's create a user table. So I'll go to create table. I'll create an ID, which will be my primary key. Create a username, which is a text column. And then I'll create password, which is also text column. And then I'll set ID to be the primary key. And because we will be fetching data by the username very often, I will make this a unique index, and also to ensure that duplicate usernames will never arise. Now let's implement a function to create a new user. So this function as an input will take the username and the password, and it will create an entry in the user table. So let's assume that we somehow have the username and password that was sent to us in the create user request, and let's create the password. So var dbstring is equal to hash password comma salt. Obviously we need to generate a salt for this user, so let's quickly generate a salt as well. So I use the get random bytes function to generate the salt. Now once we have this database string, we want to save it in the database, so we'll do a pool.query. We'll make an insert query, so insert into the user table, right? It's important to use these double quotes here because for Postgres, user is a bit of a reserved keyword, and we want to insert the columns username and password, and the values that we are inserting into it are $1 and $2, which represent two elements in an array, which are going to be username and dbstring. So dbstring is the hashed password. Once we have, so I'll write the callback here, and again we'll handle the errors in the same way. So for example, if you're obtaining an error, I'm going to copy paste the code that we had from earlier. So in case there's an error, I will reply with error, and otherwise we'll send a response saying user successfully created with the username, right? So the first problem that we need to solve is, where is username and password? Where are these two values going to come from? We can use the same method of making it a part of the URL, where we can have username and password, right, as a part of the URL. But that is not a recommended practice, because ideally we should not be sending data in the GET requests, right? Especially because the password is raw, and in case, for example, let's say the logs will be printed, and the logs will show what password is being printed, and this is very dangerous because anybody who has access to the logs will have access to the password, in which case it makes sense to make this a post request, right, and assume that we'll be able to extract the username and the password from the request body. So let's say that var username is equal to rec dot body dot username, and let's say var password is equal to rec dot body dot password. So now we come to the next question, which is where is this data coming in the rec dot body, and what is the format of the data that is coming in? So we're going to assume that this is a JSON request, and if this is a JSON request, we have to tell our Express framework to look for these keys inside the request body, and this request body is going to be a JSON. And the way to do that is to use something called the body parser, which is an Express library, and we need to tell our Express app that in case you see JSON content, load the JSON content in the rec.body variable. So we'll be doing, and so this is the way of telling our Express framework that for every incoming request, in case it sees a content type JSON, it uses that and sets rec.body. We need to figure out how we're going to test this, right? Because this is not a URL that we can, for example, do this with. For example, if you make the request to create user, it says cannot get / create user, because this is not a get request but a post request. So the question that we have to answer now is how do we make a post request and how do we test out this API endpoint that we've made? In our application, ultimately, when we use this create user API, we will be writing code in the main.js function, right, inside our request here. And instead of making a get request that we were making here when we were submitting to the name API, we'll actually change this to a post request. This is how we'll do it when we write the JavaScript that will actually use this API. But when we just want to test this out, we'll use a tool called curl. So to use curl, because you might not have curl installed on your Windows systems, let's go back to our SSH console. And I'll take my password from here. So I'm logged into my SSH console. I'm going to zoom that up a little bit. So let's quickly check out what curl does. So if I do curl, this actually queries google.com, and whatever is the HTML response of google.com, it shows that in the terminal. This is exactly what the browser would have done, but the browser instead would have displayed the HTML. Now instead of displaying the HTML, this is just going to display the HTML string here. So what we're going to do is we're going to make a request to our app. I made a mistake here. I did not put IMAD, so let me add IMAD. Right, and you can see that the HTML has loaded, right? So what we're now going to do is try to make a post request. So let's see what the post request will look like. I'll have a username and I'll have a password, and let's say that's just password, right? So this is a JSON. I'm going to expect this JSON object because this JSON object will convert into the right username and password variables. So let's go here. We're making a post request, so we'll use -x post. So this is the way of making a post request. I'm going to send some data in my post request, and I open a single quote to specify what data I have. The password is, let's just say password temporarily, right? And now let's enter the URL. So HTTP. So that's the request that we're making. Now, if you see the error that I'm getting, it's saying that it sent me an error saying that crypto.getRandomBytes is not a function. So I've made a mistake in the code that I've written. So let's go to the crypto documentation and see what, okay, so it's called random bytes. The word get is wrong. So let's remove this and change this to random bytes. Commit and restart this app. And let's make the same request again. So I press the up arrow. So the error that we're making is that, if you should read the error carefully, and it says that the pbkdf2 function is receiving a wrong value, and it's saying that it's not receiving a buffer. By a buffer, it means a string buffer. So it's not receiving the right type of value. And what that means is that somehow it's not able to access the username and password. Now, why is it not able to access the username and password? Because the username and password is probably not coming in from this rec.body here, right? And why is this JSON object not being loaded? The reason why this JSON object is not being loaded, or we're not able to extract the username and password from the object correctly, is because Express doesn't know that we've sent it JSON. So how do we tell Express that we're sending it the content type JSON in the data that we're sending? Because only if we tell Express that we're sending the JSON content type, it will use the body parser and extract the JSON value and put it in rec.body. So the way to do that is to add a HTTP header, right, and called content type. So this is the content type header, and we're submitting this content type header. I'm going to use the -v flag on curl to see the request in more detail that curl is making. Let's see what the request being made is. So it's saying that it's making a post request to the create user endpoint. It's sending the content type as application JSON. The response that it has received is HTTP 200, which means that a response was successful. And if you look at the response, it says that the user has been successfully created and the user is Tanmay. So let's go and look at our data. And so we see that this entry has been received. So now let's do the tricky bit of actually logging this user in. Login is also going to be a post request because it is going to accept the same arguments, username and password. But instead of inserting them into the database, it's actually going to fetch the value from the database to check if the value is matching. So let's copy paste this code here. We don't need to create a salt. So let's remove this. Let's remove this, right? What we now want to do is actually select from the user table. So let's do select star from, right? And we'll select it using the username value. So select it where the username is equal to $1 and $1 is the username value. So what we're going to do is first search in our table to see if this username exists. Now, if this username exists and if the SQL response is successful, we need to quickly check if no rows were received, which means that we'll send a message saying we'll send a 403, which means that it's a forbidden request, and we'll say that username or password is invalid, right? So this is the response that we sent back. And in case we do have a certain number of rows, then we know that the username exists. Now what we need to do is now we need to match the password. So first, let's extract the password that is stored in the database. So let's call it db string, which is result.rows, the first element in the password field. Now if you look at the password field, we have stored the number of iterations here. This value is the salt, right? And after that is the actual password data. So we can use the split function to split by $. So this will now return an array, right? The value of this thing will be exactly what we used in the hash here. So it will be this array, right? And so what we want to do is extract the salt value. So the salt value is the third element in the array, right? So we have the salt value now. So now let's create a hash using this salt value. So we'll say that hash is equal to so here we are creating a hash based on the password submitted and the original salt, right? And the test of testing whether this is a valid user is to test if this hashed password is exactly equal to the value that was originally stored in the database. And this if this is correct, that means that the user is successfully logged in. So we'll return a message saying credentials are correct. And if this is wrong, we'll return an error message saying that the username or password is invalid. Let's see this in action. So now instead of making a request to the create user endpoint, let's make a request to the login endpoint, right? And we're going to use the same data, username and password. So I'm seeing a 500 internal error, and it's saying that there's a syntax error that I've made, right? Which is an error that I've made in writing the code. So we are returning an error here. This is where we're returning our 500 error. And so that means there's an error in our SQL query. So if you look at the SQL query, I said select star from user, and I forgot to put the where keyword. So let's put the where keyword here. Let's make this more readable. Let's save this. Let's make a query again. Great. So that means that our credentials have matched. Let's deliberately change our credentials here. For example, let's send the wrong password, and I get a response saying forbidden, right? Which is a 403, right? That's the response that I get. That means that we've now implemented a login function, which is not actually doing anything, but it's just testing that the credentials are valid. What we ideally want to do here, we want to set a session so that once the user is logged in, the user stays logged in. But before we add session, let's actually implement the login on the UI. So that means that what we'll do is, if I go to the home page, then what I would like to do is replace all of this and change it to a login form here. So let's quickly make those changes. Let's go to index.html. Let's remove all of this, right? We don't want anything here. Let's instead change this to login to unlock awesome features. Okay, so now what we're going to do is, we're going to quickly create an input type element called type text, and make this the username field. And then have another field here which is called password, which is the input type password. We'll give this element, HTML element, an ID of password. Obviously won't have a placeholder for this, right? And then we'll have a button. And this is the submit button, right? So let's go to our main.js, right? And let's remove all this counter code that we had, right? And now instead of having the submit name, we're going to do submit username, password to login, right? So now what we're going to do is we're going to be making a post request, right? And in the post request, we'll be sending some data. So instead of sending null, we'll actually be sending data here. And the data that we want to send is a JSON string. And so let's convert an object into a JSON string. And so the object that we'll have is username. Let's assume we were able to extract the username value, and password. Let's assume that we were able to extract the password value, right? So where is this username and password coming from? As soon as the button is clicked, we'll extract it from the input element. So let's change this to username. So username will be this dot value, and similarly password will be obtained from the password element, right? So we'll extract, so every time the button is clicked, we'll figure this part later, but every time the button is clicked, we'll extract the username, we'll extract the password, right? Just for debugging purposes, let's print this out, right? We'll be making a request to the URL /login, right? That's the post request. And once this request is sent, right, we'll have to handle the end of the request. So if this request is successful, we'll have to say that the user is logged in. So we'll remove this and we'll say, right? And what we can in fact do is we can print out an alert box saying that logged in successfully, right? And in case there was an error, so let's say if the status was not 200, let's say if the status was 403, we'll say that the password is incorrect, right? And the other possibility is that the error status is 500, in which case we'll say that something went wrong on the server, right? We don't know what the error is, it's some unhandled error. So let's make sure that these are else if conditions, right? And this should be stringify. The content type here. So let's set the header here. This is the same thing that we did in curl. Let's again save this. Let's reload this page. So we have a page load here. Let's load up inspect element. Make sure this is half the page. Head to the console here so that we can see what's going on. Clear the console. Let's make a request. And I clicked on submit, and I get a alert box saying logged in successfully, right? It's printing out the debug things. If you go to the network tab, you'll see that the login request is made. It's a post request, right? And saying a response credentials correct. It's sending a JSON object, right? It's sending the right content type, application JSON. Let's change this value to something else. Click on submit, and you'll see the username password is incorrect. If you look at this request that's being sent, it's responding with a 403, right? Exactly like how we were testing out with curl. So now let's get to adding sessions. So when we add a session, what we mean by that is that once the user is logged in, there is some way of telling the client that take this particular session ID, and if you have this session ID and you ever make a request again with the same session ID, then I'll know that you were the same user who made the login request. So that means we need to respond with a particular session ID, and the client needs to remember that session ID and send that back to us next time. Since this is a very common functionality, there are several libraries to do this, and we'll be using the node session library to do this. To make it easy to send the session ID to the web client and for the web client to repeatedly send us the same session ID again and again, we'll use cookies. Let's use the express session library to do this. Once again, I have to tell Express to use the session library. When I use the session library, there are two configurations that I need to give the session library. One configuration is the secret, which is a value that it will use to encrypt the cookies with. So I'll just set this to some random value for now. Right? And we have to tell the session library that when it creates cookies, the cookie should have a particular age. So we'll say that the cookies, and so we'll say the cookie can have a max age of, so this value is specified in milliseconds. So we'll say 1000 into 60, which is 1 minute, into 60, which is 1 hour, into 24, which is 1 day, into 30. So all our cookies are long-lasting cookies. They last for a month. Once the cookie is set, it will be set for a month. So now we can come back and try to set the session value. We have to set the session value before we actually send the response. So let's move this up here. So let's set the session as rec.session.auth is equal to user ID, which will be result.rows of 0.id, right? So what we've done here is that we've assumed that there is a session object on the request, right? Just like we assumed that there was a body on the request which was created by body parser, we're assuming that there's a session object on the request which has been created by the session library. So there is rec.session. We are saying that there's going to be a key called auth inside that object, and that key will map to this particular object. And what is this object? This object says that there is a user ID, and the user ID value is equal to the ID of the user that we've gotten from the database. So what is actually happening in the background? So in the background, what is happening is that the session library, or the session middleware to be technically correct, is setting a cookie with a session ID, right, that it is randomly generating by itself. Internally on the server side, it maps the session ID to an object. What does this object contain? This object contains a value called auth. And what does auth contain? Well, auth in turn contains another object, which is our user ID object, right? So this information is maintained on the server side. All that the cookie contains is a session ID, right? As soon as we do this here, the express session library will automatically make sure that this object is saved internally as soon as the response is sent. So how do we test that this session object has actually been created? Let's create another endpoint which we can use in the browser called check login. And what this endpoint will do is that it will check that if there's a rec session object, and if there's a session object, it will check if there's an auth object inside it, and if there's an auth object, it will check if there's a user ID key inside this auth object, and if there is, then we'll return a response saying that you are logged in and the user ID that you have is rec.session.auth.user_id, right? And this is an integer, so let's convert that to a string. So this is the value here. In case none of these objects are found, we know that the user is not logged in, so we'll return an error saying you are not logged in, right? So let's put this in action to see if sessions are working for us. So let's enter the username and password. So we're saying that we logged in successfully. Let's now go back to the check login and you can see that it's saying that I'm logged in as 1, right? So now let's try to implement a logout function. So let's say that there's a logout endpoint, which is again a get request because no data needs to be sent. And if this happens, what we'll do is that we'll remove the auth object, right? And so this deletes the auth object from the session object, right? So that means that we're not storing this session anymore, right? So let's send a response saying that you're logged out. Let's save this. So I refresh check logged in. I'm not logged in. Every time I refresh the browser, because the internal session objects are reset, then the sessions are lost. So I don't stay logged in because when I restart the server, the session object that is maintained internally is lost. Let's go back to our login page and enter a value here. I'm logged in successfully. So now let's go to check login and I can see that I'm logged in as 1 and keep refreshing this. Let's now call the logout endpoint. Logout endpoint says that I'm logged out. Now let's go back to our check login and it says that you're not logged in, right? Because this session object that we were maintaining has been deleted by us, right? So this is how we implemented a very simple login and a logout functionality, and we also maintained sessions. So now let's put together all the knowledge that we've gained so far and create a registration experience. We should check if the user is logged in and we should use that to show if there's a registration form, then to show a logout button. We can then add a comment section to all the article pages, and if the user is logged in, then we should allow the user to submit comments. But even if the user is not logged in, we should be able to see all the comments. You should try to do this exercise by yourself to sort of really seal your knowledge about how APIs work, how sessions work, how login works, how the database works, how front-end JavaScript works, and how back-end JavaScript works. I've created this application myself, so let's have a look at what this application looks like. So I try to register with the new user, say user 5. User has been created successfully, so now I'm registered. So now I'm going to try to log in with the same credentials. So I try to log in. As soon as the login is done, this area changes to a logout section. So I can go to any particular article. Let's say go to article 1. There are no comments here, so I can post a comment saying this is a comment by me, user 5, and let's post this comment. This comment has appeared. Let's go back to the home page. Let's log out. And now if we go back to article 1, we'll see that the comment remains there, but the box to insert the comment has disappeared, right? All the source code for this is available on this GitHub repository, so you can use that for a reference. A new comment table was created to be able to store comments, and you can check the SQL for that again inside the GitHub repository. You can also use these screenshots of adminer to see how this comment table was created. So the important thing to remember as we bring this module to a close is that this entire exercise is educational, and you should try not to implement things like password hashing completely manually like we've done ourselves. Ideally, for example, if you're using Node.js, you should use a library like passport.js to make life easy. And almost all other languages and frameworks provide a kind of system to take care of authentication so that we can ensure that the implementation is secure and easy to do.